Hi everyone. Okay, so we are at the worksheet 4 now. In the last lesson, we learned that radian measure, when it comes to circle related matters, radian is simply a different unit of measurement. Just like we can use degree to measure things, or we can also use radian to measure things. So radian is just a different unit. Okay, so they are essentially have the similar function, just like you can measure length with cm, meter, or you can measure it with as compared to inches or feet, So it's actually the same thing, same calculation, but measured in a different unit, right? So in the previous lesson, we have learned this, okay? So we're going to start first by looking at arc length, okay? So arc length, I hope you guys still remember, is actually looking at the side here, okay? This length here is actually a small part of the full circumference. Now, if we were to find the arc length based on the previous lessons, we have already learned this is actually taking the circumference, which is your 2 pi r multiplied by theta over 360 degree, because a part of it, right? If it's a full thing, it'll be 360 over 360. If it's a full circle, it'll be 360 over 360. You cancel, and then you'll get a circumference. But if it's not a full circle, it'll be theta over 360. It depends on what your theta is. Theta is right here. Okay. Now, if now we are going to look at the calculation in radian form, okay, in radian form, as what we have learned, in radian form, we can also calculate it using 2 pi r times theta, but it's no longer over 360. Length of arc is now theta over 2 pi times 2 pi r. Reason is because full revolution, that means one full circle, is either we say that it is 360 degree or we say that it is 2 pi. So you see that we either use 360 or we use 2 pi. Depends on whether you're using degree or radian. Okay, in a radian mode here, draw too long. 2 pi and then the 2 pi and 2 pi here, after you cancel, you get r theta. Okay, so s is equals to r theta over here. Okay, write down there's a formula. S is equals to r theta, where the r is a unit, is a radius, and theta is in the radian unit. Okay. Of course, the theta will be the angle that is subtended by the arc at the center of the circle, right? So, and then from 8.2, we have also learned this, how to calculate area of sector. But what we learned was that the calculation is in degree. Okay, whereas this is area of circle, right? Pi r square is area of circle. This is something that we learned before, right? And then in the previous worksheet, you also learned that to find a area of a sector, a pizza, is actually theta over 360 times pi r square. Now, if now you are going to learn to calculate in radian mode, then coincidentally, once again, I will change this to radian mode. Okay, in radian mode, it will be divided by 2 pi rather than divided by 360. Now, similarly, just like the arc length, you see that if you use radian, the pi and pi can cancel each other out, and I get a simpler formula here. Is actually half r squared theta, whereby the theta is going to be in radian mode. Okay, so this is a formula that you can memorize. So A is equal to half r squared theta, but you only use this if this is a radian mode. Okay, if you use degree mode, this is wrong. You cannot use degree mode on this formula. It must be in radian mode. Okay, then what about area of a segment? Do you remember what's a segment? Right, what I said before, segment is a very barbaric way of eating a pizza. You cut it like that. This part is called a segment. Okay, so how do I find the area of the segment? Okay, to find area of segment is simply equals to get the pizza minus the triangle, then you get this small piece. You see that? Okay, so pizza is actually half r squared theta, as what we learned just now. The triangle is half r squared sine theta. then in this formula, we'll get it. Then we can find the segment, and we are done. Okay, so you have a table here that shows you a comparison between your degree and the radian. Okay, so to find arc length, if you use degree and radian, the formulas are represented differently. Okay, so the one on the left hand side, please remember, is only applicable for degree. The one on the right hand side is only applicable for the radian mode. So the area of sector, also same thing. Area of segment is also the same thing. Here, I want you to pay attention to the last line here. Okay, we have a separate line here. This is what I have written just now. A separate line below that shows half r squared bracket theta minus sine theta is actually a factorized form of what we have here. I'm going to highlight for you to see. Do you see half r squared? This one also have half r squared. Since both of them have half r squared, I can factorize it. So what you have in the second line here is actually the same formula, but they factorize a half r squared. Okay? Actually, this one, if you ask, sure, can I factorize the one for degree? You can also, because this one is r theta, this one has r theta. Okay, you can also factorize it, but it's not conventional for us to do that. Okay? Now, let's start by attempting some questions. Okay, this is a video recording, so if you want, you can pause or you can go back and re-look at it again. Okay? Now, let's read the question properly first. It starts with AB lies on the circle, and then a radius 10 cm, AOB is 2.3 radians. Right, highlight this. Okay, everyone, highlight this. 2.3 radian. And then the length of the major arc is what they want you to find. Okay, major arc. Right, so if you want to find the length of the major arc, you first need to find out the reflex angle here. Okay, so I need to first find a reflex angle because major arc is, I'm going to draw it for you to see, okay, is this red color part over here. They want you to find the arc length on this side. Now, in order to find arc length, you need two information. One is a radius, one is a angle, theta. Okay, where in this case, it is in radian mode. Radius we have already, which is 10. Radian, we don't know. So it's something we need to find out. How do we find? Okay, we know that, okay, let's write down first. Reflex AOB, okay, is the one outside. We know that one full circle is 2 pi and the other side is 2.3. So we just need to write that down. Reflex angle is 2 pi minus 2.3. Do I need to find out the full form? No need, because this is not the final step. Okay, we can leave it as accurate as possible. The final answer is not asking for the reflex angle, right? They're asking for the length of major arc. So I'm just going to leave it like that. And then the next step will be major arc length AB would then be equals to r theta. Okay, there's a formula that we have just now. You can pause the video and go back and see the previous part. Okay, so then the angle is 2 pi minus 2.3. You will get 39.8315 SF. And then you can round it off 39.8 cm. 3 significant figure. Okay. Example 2. ABC lies on a circle with a center O and radius 4, and AOB is 2.5. Okay. So part 8, they ask you to find the highlight area of minor sector. So they are asking for minor sector. So if we want to find the minor sector here, what we can do here is we need to consider which side we are calculating. Minor sector is this part over here. Okay, if you are going to follow me and draw, please use pencil. I can erase it from here, but yours, if you use pen, you cannot erase. So this is the minor sector. So in order to find the minor sector, to find area, I need radius and I need the theta. Radius I have already, theta I also have already. This is 4, this is 2.5, and the formula is half r squared theta. Okay, so I have everything I need. I don't need to go and find other things, so I can straight away just copy what is required. Remember, you must write down the statement and state what you are finding to be clear. Okay, so this will be half r squared theta. It will be half times 4 squared. Theta is 2.5. Okay, so you get that this is 20 cm square. You get an exact number here because you look at a calculation, there is no pi involved in this calculation. Okay, so B part 1, now they want you to write down in terms of pi. So can you highlight this? In the previous test, many of you missed it out. So in terms of pi, um, for the reflex angle of AOB, so don't find the wrong thing. So reflex AOB, okay, reflex angle AOB will be equals to 2 pi minus 2.5 radian. That's it. You just leave your answer like that because they want it to be left in pi form. Okay. Then next, also in terms of pi, they want you to find the length of arc ACB. So I can find length of arc ACB. I can directly find that, right? ACB, okay, I'm going to erase everything here. Okay, let's take a look. ACB is this side over here. Okay, how do I find the length of arc? Okay, so arc length, if I want to find it, the formula is R theta. Okay, the length of R is R theta. So I need radius and I need theta. Do I have the radius? 4. Yes. Do I have the theta? Yes, because I found that this is 2 pi minus 2.5 in the previous part. So I have everything I need. So if I want to find the length of arc, I simply just do R theta. I will need extra step if I don't have all the information, but here I have everything. The radius is 4. The theta is 2 pi minus 2.5. Okay, so it's 8 pi minus 10. Okay, so this is in terms of cm. Put a bracket. Now, can we leave an answer like that? Yep, because they want your answer to be left in terms of pi. Okay, so we cannot calculate it out. We have to leave it in pi form. If not, you will not be answering the question. Okay, so example 3. PQ are points on the circle O. Circle with the center O. And then you have your angle POQ as 1.8. So I have radian, I have radius, looks good. So part 1, I will want to calculate the perimeter of the minor sector POQ. Okay, so let's look at this POQ, sector POQ. Okay, highlight. This word minor is very important. It tells you whether you want to find a big one or the small one. Okay, the minor sector POQ is over here. So if I want to find the perimeter, what do I need? Once again, I need radius. I need the theta. I have this. I have this. Clear. Simple. So perimeter of minor sector POQ will be equals to the two radius add together first. 6 plus 6 plus r theta. Okay. The formula of r theta will be 6 bracket 1.8. It's given to us by the question. So I get this whole thing is 22.8 cm. Okay, once again, you don't have to put 3SF because it is an exact number. Second part, the area of the segment shaded. So now here comes a shaded segment. That's what we've seen just now. Area of shaded segment. So how do we calculate this? Now, to find the area of shaded segment, okay, we need to take the pizza minus a triangle. Pizza is a sector, half r squared theta, minus half r squared sine theta. Okay, minus a triangle away. Then you will get the shaded segment. So it's half 6 square 1.8 minus half 6 square sine 1.8. Remember, this only works if you are using radian. Please don't go and use degree and tell me that you can get the answer. Okay, you cannot. So when you do this, okay, take note here, calculator must make sure that it is radian mode. Go and check, okay? Make sure it is in radian mode. I will urge all of you to pause this video to go and press calculator and see whether you get the same number. If you didn't, means that, hey, maybe your calculator mode has to change. Maybe you forgot to change. Okay, so what we have here is 14.8. Sorry, this, if you round it off, is 14.9 cm square 3 SF. Okay, next question. Example 4. The diagram shows a sector of a circle and the radius, so they want you to calculate the shaded area. Now, shaded area, and somehow they give you in degree. So for the sake of this worksheet, let's do everything in radian mode. Okay, so the shaded area, basically what they are asking you to find is the segment. Okay, it's an awkwardly cut pizza, remember? So to find this, what we do is we convert 102 degree into radian mode first. How do we convert? Okay, I'm going to pause here for 1 second so that you can pause the video and go and think first. Yep, I hope that you are correct. So it's divided by 180 times pi. Okay, so you get that this is 1.9548 radian. I mean, you can leave it in pi form or you can calculate it out like that. So I just calculate it out so it's easier to see. You want to leave it in pi form, actually that works as well. So the shaded area, now I can start to calculate. Remember, if you're finding the area of a segment, is one big piece of pizza minus the little triangle. The little triangle will have the sign over there. Okay, so the shaded area will be equal to half 15 bracket square times 1.9548, then I minus away half 15 square sine 1.9548. Sorry, what I get here is 115.615 SF, and my final answer is 116 cm square 3 SF. Okay. Example 5, 10-year series question, 2010. The cross-section of a tunnel, okay, is shaded in the region below. Is a major segment of a circle. So actually, if you look carefully, it's actually a full circle. There, they remove this part. Okay, then of course, so that maybe a car can go past here on a flat road, huh? Okay. So the total perimeter of the major sector, highlight this, major sector POQR. So let me just draw it out for you to see. POQR, although they shade the whole thing, but this part of the information is not about the whole thing, it's only about this segment here. Sorry, this sector here is without the triangle. So you must read the question very carefully. Okay, major sector POQ, because the moment you see the word sector, it should always look like pizza. This is not a pizza. Okay, so they tell you the parameter. So part 1, this one actually should be here. Okay, part 1, they want you to find in radian mode what is the reflex angle of POQ. Okay, so they want you to find POQ now. In order to find this, we will first have to use the perimeter that is given to us. So part 1, the total perimeter, what is it? POQR is equals to 44. So I know that this arc plus these two lines is equals to 44. So 8 plus 8 plus arc length PRQ is equals to 44. Okay. So I can find that arc length PRQ is equals to 44 minus 8, which you get 28. Now, in order to find arc length, We know that it is r theta. We have the r, we don't have the theta, but this is exactly what the question part 1 is asking. They want you to find the radian. So it will be 8 theta equals to 28, where theta is 28 over 8. Okay, which will give you 3.5 radian. So we are done with the question. They want us to leave the answer in radian mode. Okay, now part 2. They want you to find the area of the triangle POQ. Okay, triangle POQ. So you have to read the word carefully. They say triangle, so it's this part over here. So to find the area of this triangle, before we start, let's look at this. If I want to find the area, it will be half r squared sine theta. So what do I need? I need the radius, I need the theta. Do I have the radius? Yes. Do I have the theta? No, I don't have. But I can do 2 pi minus 3.5, okay, as found here, because the angle outside here is actually 3.5. Okay, once I do this, I will be able to have all the information. So rather than saying no, I actually can. I use the answer from part 1. Okay, so triangle POQ, half r squared sine theta. My r is 8 square sine 2 pi minus 3.5. Okay, because the angle at the other side is 3.5, right? So you key in the calculator, you get that this 11.225 meter square. Take note that it is in meter. It's a tunnel for car. So then it'll be 11.2 meter square, 3 SF. Well, I'm leaving it in 5 SF because I will need this number in the next part. Okay, so part 3. They're asking for total area of cross section of the tunnel. Total area of cross section. Okay, so it will be equals to what? So let's take a look here. Area of cross section. Okay, I can find this area of a sector plus this little triangle below, okay, which I found in part 2. Then I'll get my answer. Okay, so I will just need to take area of major sector PRQ plus area of triangle POQ. So this is the formula. Major sector, half r squared theta. I can fill in a r, half 8 squared theta. We calculated is 3.5 plus area of triangle, we use a 5 SF value. And then when we calculate, we get 123.225 meters square. And final answer is 123 meters square, 3 significant figure. Okay, this is 6 SF. And I get my answer. Okay. Now, homework. So I need you guys to finish all this and submit on Microsoft Teams. Okay, I will put it up there. Your deadline would be on the 5th August. Okay, which is on the Thursday. Okay, Dominic, I need your help to collect the homework for me, okay? Make sure I remind everybody to submit. You don't have to collect because it's submitted digitally.